Uh, Good afternoon. I'm here again to talk the classification part, and I yesterday discussed about what is image separability analysis, and then supervised and unsupervised classification with the definition of classification. So now in this continuation today, as is my second lecture and the last lecture in this topic, I have to cover the assessment of thematic map which has been generated through image classification. So here when we go for accuracy assessment of a classified map, that means we have some classified map here for an example, and in this we have a few classes like water, then we have here forest, we have here agriculture. So this is a classified map. So this is a classified map. Suppose there are three classes: water, forest, and agriculture. We have map. Now to assess its accuracy by how accurately this map has been generated, we require the reference data or reference map. So here I can show you the one more map which has been borrowed as a reference map, and using this reference map we can do accuracy assessment of the classified map. So here in the reference map again we have a water body, then we have here forest class, and we have here agriculture. So this is a reference map. Now to generate the error matrix, so we should have here 3 by 3 matrix. So we can draw here a few rows and columns. So we can here have the water class column, then forest class column, and then agriculture class column. Agriculture again here water, forest, and agriculture class column. On the column side we will have the reference data, and here we will have the map data. This will be the map, the classified map. Now to check the accuracy of the thematic map, we require some testing samples. So testing samples can be randomly generated or stratified random. If it is randomly generated, then and if we select 20 points, so they are randomly distributed. There can be uneven distribution of the samples through random approach. But if it is stratified random, then in that case there will be few samples in each class. Suppose if I take one random sample suppose it comes on the water class, if I see on the map, and same location if I see on the reference map, it comes again on the water class. So how to fill the error matrix? On the map it is water, and on the reference map also it is water, so this will come here. Then you take second sample, it comes here on the forest class, and same location if you see on the reference map, it is forest class. So in the table it will be coming forest on the map and forest on the reference, it comes here. If you take third sample, it come here to be water on the map, and here it comes to be forest on the reference map. So on the map it is water, and on the reference map it is forest. So the sample location will come here on the in the error matrix. So like this we can go on filling the sample. We can take one more sample. On the map it is agriculture, and on the reference map it is again agriculture. So the sample will come here agriculture, and agriculture it will come here. Then you take one more sample, suppose here it is agriculture on the map, and on the reference map it is coming as a forest. It is coming here somewhere here, forest. So here if you see, this will go on the map it is agriculture, and on the reference it is forest. So sample will come here. So like this you can go on filling the error matrix till a total number of samples are tested on the map and on the reference map. So if you do this, the matrix will look like this. So here you can see again for 3 classes, once you finish all the testing samples, the matrix will be looking like this. Right? And then we can, once we have this error matrix, we have to go for total, that is for row total. For each row we have to calculate the total. Same way for each column we have to calculate the total. So this is your number of ground truth pixels, and that is your column total. So here you can see row total. For the first row it is coming 39, for second row total it is 50, and third row total it is 47. For column total it is coming here 50 for class A, 40 for class B, and 46 for class C. So from this error matrix we can calculate lot of parameters, and also if you go for total row column or total column total, it will come 136. This will come 136. Now we can proceed the different parameters what we can calculate from this error matrix. The first parameter is user accuracy, and for each class we can calculate the user accuracy. The user accuracy tells how correctly the samples has been identified on classified map. So whatever classified map we have generated, here we are collecting the testing samples. So to know by what accuracy the user samples has been the samples has been identified on the classified map, that is known through user accuracy. So here for example we have taken for class B, what should be the user accuracy? Here if you see the interpretation, total samples which has been used on the classified map, it is 50 here. And if you see the distribution of these 50 samples, 10 has been gone to class A, 37 has been correctly identified for class B, and 3 has gone to class C. So if you want to calculate the user accuracy, this will come here 37 divided by total samples on the classified map used for class B, that is 50. 37 by 50 into 100, then it will be 75%. The user accuracy is shown in percentage. So 37 by 50 multiplied by 100, that comes 74% for class B. Now if you take 100 minus 74, that comes to be 26. So this is called error of commission. Then second parameter, and this user accuracy you can get for each class. So you can have user accuracy for class A, for class B, for class C. So for each class you can get the user accuracy. For class A it will be 35 divided by 39 into 100. For class B we have already shown 37 by 50 into 100, and for class C it will be 41 divided by 47 into 100. Now coming to producer accuracy. The producer accuracy reflect how correctly we have identified the testing samples on the reference map. So again, the producer accuracy will be for each class. So if you talk about class A, you can see 35 samples has been correctly identified on the reference map, and total samples used are 50. Out of 50, 35 has been correctly identified for class A, 10 has gone to class B, and 5 has been identified as class actually for C. So for producer accuracy, the accuracy will be for class B 37 by 40 if you multiply by 100, and if you are calculating for class A, it will be 35 divided by 50 into 100, and for class C it will be 41 divided by 46 into 100. And again you can calculate one more parameter called error of omission. So error of omission for class B will be 100 minus 93, that is 7%. Third parameter we can calculate from error matrix is overall accuracy, OA. So overall accuracy in this case will be diagonal sum of this error matrix, that is your 35 plus 37 and then plus 41 and divide by total samples. So total samples here are coming to be 136. If you take all the row totals or all the column totals, the summation will come 136. So here that is your total number of samples used for testing the classified map. And if you multiply this by 100, this will give you overall accuracy of the classified map. So this is the third parameter. The drawback of overall accuracy is we are using only the diagonal parameters. So to incorporate the off diagonal parameters, one more variable has been designed, and that is called kappa coefficient or KHAT. It is also written like KHAT, KHAT. So here you can see its formula. Capital N is total number of samples, that is 136, summation xkk. Summation xkk is the summation of diagonal elements, that is 35 in plus 37 plus 41 minus summation x k plus into x plus k. So here you can calculate the corresponding class row total with column total. So that is your 39 into 50, then plus 50 into 40 plus 47 into 46. So that will be this value, and here in the denominator n square, that is total number of samples, that is 136 square minus summation x k plus into x plus k. So that is again your 39 into 50 plus 50 into 40 plus 47 into 46. So this will give you this value, and if you solve it, it will give you some value which will be going from 0 to 1. Please remember the kappa coefficient and or the KHAT is represented as 0 to 1 value in decimals. So it is not coming, or it is not represented in the form of percentage. So if you put it the values, you will get its value around, I think 0.74 you will achieve in this case for the example. And this way we can calculate the 4 parameters from the confusion matrix or error matrix. That is your user accuracy for each class. It is representing how correctly the testing samples are picked up from the classified map. Producer accuracy means how correctly the samples are picked up on the reference map for each class. Then third variable is overall accuracy. That is, if you take the diagonal sum of the error matrix dividing by total number of samples multiplying by 100, that will give you overall accuracy. And then you can calculate the kappa estimates or kappa coefficient by this formula, and you can get the value from of cart between 0 to 1. So because here, if you note down, the kappa coefficient is using the off diagonal elements also. So people believe more good level of confidence in kappa coefficient than error matrix. But nowadays people are not considering much weightage to this these parameters like user accuracy, producer accuracy, kappa coefficient, and overall accuracy. People are looking for the accuracy of the map should be represented by one more variable, that is called F score. So F score you can go through with the different YouTubes. Basically it is using false negative, false positive values from the two classes, and from there you can generate the two variables, that is called recall and precision. Using recall and precision, you can put up the formula, you can put up these values in the formula to get F score. So people believe more reliable accuracy variable through F score than overall accuracy or kappa coefficient. So this was the today's lecture I have to cover. Thank you all. I can just recap what I've covered yesterday. I started to give you mathematical understanding of image in the form of rows and column with the digital values and the multiple layers. And then I talked about the topics which I covered, that is separability analysis. That is basically to know what minimum bands can be used which can give maximum separation between classes I'm looking for. And you can have a subset of spectral bands from the given image, and you can get the maximum separation while using the minimum number of spectral bands. And this separability analysis you can do once you generate the signature file in any of the commercial image processing software. There in signature file generation, you will find one option called separability analysis. Through separability analysis, you can find out, if you take only one band of the image, which band can give you the maximum separation between classes of interest. Then you can take second combination, two bands at a time. Then again it will tell the band combinations, and then you can find out which band combination is giving maximum separation between classes you're looking for. Then third band combination, fourth band combination, like that you can go on going, and then find out with number of bands combinations which is giving the maximum separation between classes, and that band combination you can select. And in the commercial tool, you can do separability analysis while using the graphical method or Euclidean distance method or Zaffre-Matsushita distance method or transform divergence method. Then I talked about yesterday about the definition of classification, that is digital image classification, why we should go nowadays the digital image classification, because we have large number of images to be processed in very short time, that is possible. And then type of classifications like supervised and unsupervised. In unsupervised we don't require any training data, but in supervised we require large training data, and we can follow some rule like 10n given by Jensen, where n is the basically number of bands, and by that you can know what should be your training data size to train the model. And I also defined the category of these classifiers. They are pixel based, they are statistical classifiers, they are parametric and hard classifier. And then I talked about for supervised, for unsupervised, only one algorithm which is using very simplest mean parameter, that is called C means. And for supervised, I talked about 4 algorithms, that is minimum distance classifier, that is again C means, then Mahalanobis distance classifier, then parallelopiped or box classifier, and then last one was the maximum likelihood classifier, which is using probability. And we have to see for a particular class the probability should be maximum while assigning the label. And today I talked about the confusion matrix or error matrix, and there I talked about how to generate this matrix. We require the testing data or the reference data, and then we can take the random sampling or stratified random sampling, and then we can generate we can pick up the each testing sample, and we can fill or generate the error matrix. Once we generate the error matrix, we can calculate the user accuracy for each class, which represent the how correctly samples, the testing samples are on the classified map. When we go for producer accuracy, then this talks about how correctly the samples are taken from the reference map for each class. So for again, for producer accuracy, we can get for each class. And third parameter was overall accuracy. While considering the diagonal elements of the matrix, we can get the overall accuracy, and the last one was the kappa coefficient or CART. For testing samples, there are different theories to define what should be the testing sample size. One of the theory given by Congleton 1991, he says that we should have around 75 to 100 testing samples per class to test our classified image. And if you want to read further on this topic, I have one. I hope this will play. No. This is not working. Anyway, I published two books, but they're more advanced one. If you want to read, you can go through, if you have that in your library. That is called Fuzzy Machine Learning for Remote Sensing Image Classification. And second one was multispectral, multi-sensor and multi-temporal remote sensing for specific class mapping. And I would like to announce, I told yesterday also, I'm conducting very advanced tutorial under IIRS 2024, which will be held at NIT Goa in the first week of December. And if you are interested, presently the tutorial on AIML for specific class mapping is on. To register, and you can see on my LinkedIn and as well as on the Facebook, the link is given, as well as on the IIRS 2024. If you type on that web page, the tutorial link is given, and you can register. There is a one-day tutorial, and maybe of course you can attend the conference also if you are putting some paper. So thank you all for my 2 days lectures on image classification and its accuracy assessment.